So let's talk for a second about blood type. So blood type is, what this is defining is the proteins that are on blood cells that kind of define them. So somewhere in evolution, anyone with A-type blood had a protein that was labeling all the blood cells and said, hey, we have this very specific kind of protein that labels us as self. So remember that all of our cells in our body have to be labeled as self, so they're yours, so nothing else comes in. So anytime any kind of invading cell comes in, your body will attack it if it doesn't have the marker that says, no, 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 I'm yours, don't attack me. So somewhere in evolution, there were two forms of this protein created. There's actually a whole lot of different ways to type blood, but this is the one we understand the best, and one of the kinds we understand the best, so we go with it. So somewhere in evolution, there was a protein called A protein. And so if you have type A blood, what that means is you have all these proteins on your blood cells that are called A. So we just call them A because it's less complicated. So if you have this protein called A so these are red blood cells with the proteins on them. These are called antigens. Okay, so the protein is called an antigen. Protein. Antigen. And then we have antibodies in our blood that are specific for certain antigens. So antibodies look for foreign antibodies. Or sorry, you can't see it. Antibodies look for foreign antigens. And that'll tell them, oh no, we've seen this before and it's bad. So somewhere in evolution, people who had A-type blood developed these antibodies that are anti-B. So what that means is anytime they find a B protein, they're going to attack it and they're going to make sure the body destroys it. Okay, so if for some reason you gave somebody, like if somebody got a blood transfusion who had A-type blood, and they got a blood transfusion, and suddenly they had a B blood cell, so a blood cell that was labeled with a B antigen. Here we go. Well, so the B antigen is not self. So if this is somebody with type A blood, they have A antigens on their blood cells, they have B antibodies in their blood system and just floating around, and anytime a B antibody tags something as having that B protein, that tells the rest of the body, oh my god, this is a foreign invader, get it out. And so by having that tag on it, your white blood cells will come in and they'll know to attack this cell because it's not the type of cell that should be there. It's an invader of some sort because the antibody said, oh no, danger, danger, kill this thing. We know it's bad. Okay, so A blood has A proteins on all of the blood cells. They have B antibodies floating around in the blood system, in the bloodstream, so that anytime anything labeled with a B will get attacked, and then that's a problem. So this is where something called agglutination happens, where if you're type A blood and you're given B blood, your antibodies will be alerted. You'll start breaking down all the blood that's coming into your system, and when you break down that blood, you release hemoglobin into the system. It starts creating these huge clots, and then you go into organ failure. So it's very bad. You don't want to get the kind of blood that you have antibodies for. You want to get the kind of blood that you have the same antigens for. So if you have B blood, it's the same thing, but reverse. So your blood cells have the proteins that we call B. Okay, so each one of these blood cells has a B antigen on it. And somewhere in evolution, people with B-type blood developed A antibodies. So you also have in your blood system, in your bloodstream, all these A antibodies floating around to make sure that nothing with an A tag on it, an A marker, an A antigen, comes into the system. And if it does, it will destroy it. Okay, so what if you have AB blood? If you have AB blood, your blood cells have two markers. They have an A, then they have a B. So every single one has an A and a B, which means you cannot have any antibodies, because if you had an A antibody, you would attack your own cells. If you had a B antibody, you would attack your own cells. Okay, so somebody with B blood cannot donate to someone with AB blood, because that person would then also be donating those. Well, actually, no, they could, because these antibodies are not involved. Okay, so somebody with AB blood is called the universal recipient. I think that's what they're called. That is not how you spell that. Receiver. Universal receiver. I think that's what it is. Which means this person can accept any blood. Accept any blood type. because they don't have any antibodies. No antibodies to blood. Okay? At least they have no AB antibodies. So they can accept A blood because they are not going to attack this is B. They can accept B blood because when you give blood, the antigens, the antibodies are left out. And so if they accept B blood, if B blood comes in here and it just has a B, well, there's nothing saying attack the B. If they accept A blood, there's nothing in here saying attack the A. So AB blood types can accept A or B blood types. So that's your universal receiver. So type O blood, what this originally meant, that O actually meant 0. And what it meant was there are no antigens. Okay, so these cells are unmarked completely. And so if they're unmarked completely, that means you have antibodies in the blood on the lookout all the time for A antibodies and B antibodies. So these are always, ever vigilant, making sure if a single blood cell comes in here that is marked with A, then this guy's going to come and it's going to alert those white blood cells to come and kill that cell. And you get agglutination and, again, organ failure. Okay? So type O blood, since it has no markers, can be donated to anybody. So this is a universal donor. Universal donor. Okay? Because when you give blood, again, the antibodies aren't involved. It's just the blood cells, okay? But when you receive blood, what you worry about is what antibodies you have that the blood cells coming in could attack, okay? Because if your own body attacks blood coming in, you could die from organ failure, from agglutination. So, yeah, that's the base. So that's the ABO blood system. So this is the ABO blood system. Now, the way these are passed down, if your parents, let's say you have a mom who is type A blood type and your dad is type B, then that means your kid, it can be several different things. Your mom could be what's called homozygous dominant, or just homozygous. She could be type A. Both of her genes for this from her parents could be A, or she could be just one. She could just have one active gene for A blood type and then an O, basically. So one gene's there. That's all you really need. Your dad could then be, if your dad is type B, then he could be big B, or he could be big B nothing, okay? Big B 0. Which means kids from this cross could have any blood type, basically, okay? But if your mom, get out of the way, if your parents are type O, so if they're O, they can only be O. And dad can only be O, because if there's any, it's not a normal dominant recessive trait type where if you have a big A and a little a, then the big A does something. No. It's merely the presence of the antigen at all that causes the blood type. So if your mom is type O, that means she has no genes for this specific blood type. Same with dad. They can only have kids. If you have two people with type O blood coming together, they will only have kids with type O blood. Now, if you have AB blood, what that could mean is that your parents, this is not the right way to do it, so if you have AB blood, it could be that your mom was A and your dad was B. Or it could be that they were both AB also. AB. Okay, so really, the important part of this is knowing what the antigen-antibody situation is. So if you are type A blood, that means your blood cells are marked with the type A protein, and you're going to attack the B proteins. So you cannot ever accept, so this cannot accept B, okay, because it'll kill the B. B blood cannot accept A. The universal receiver can accept anything. The universal donor type O cannot accept anything except O. Anything except, I'm spelling that wrong, aren't I? This should be except. Oh goodness, embarrassing. Oh, I don't think so. Oh no, I did it right. Oh, you guys, I'm so tired. Okay, cannot accept anything. Any universal donors can accept any blood type. If they take in A, they don't have antibodies for A. If they take in B, they don't have antibodies for B. If they take in O, there's no antibodies involved at all, antigens involved at all, so there's no antibodies for them. On the other hand, type O blood cannot receive anything with A or B proteins. So type O blood cannot receive A, B, or AB blood. because it's got those antibodies all the time. They're on the lookout for any cell that has A or B proteins on it. Now you might be wondering, what about if I'm B negative or I'm AB positive? What does that mean? So that's another blood typing system called the RH factor. It's called RH because it's named after the rhesus monkeys, because that's where it was first discovered. And what that is there's another protein on here. There could be another protein on here called the RH factor. If you have the RH factor, then you're considered positive. You're positive for the factor, okay? So this person, now that I put this RH factor on here, they would all have that factor, and now this person is A positive. If I don't put that RH factor here, then that means that this person is B negative, and there are antibodies in the blood with that, looking for that RH factor. Because just somewhere in evolution, the body decided, if I see that RH factor, and it's not one of my own, if I don't make it myself, I'm going to attack it, and I'm going to kill it. Okay, same thing over here with the AB blood. If you don't have that RH protein on that antigen on your blood cells, then you're a negative. If you do have it, like over here, you're positive. So you could be AB positive, AB negative. You could be O positive, O negative. It's a different protein that you're looking at in that case. Remember, that's important because when giving birth, so if you have, so in your first pregnancy, okay, so first pregnancy, if you are a RH negative mom with an RH positive baby, okay, there's a point in pregnancy where all of a sudden the blood starts leaking from the placenta. It's very, very late in pregnancy. Usually it's not until birth actually happens. And these blood types start interacting. Well, if these blood types interact, then the RH negative mom is suddenly really on the lookout, and it starts produces a whole lot of RH RH antibodies. And remember, the antibodies are what are on the lookout so that if that protein is ever seen again, it attacks whatever is holding that protein, which is, at their first baby is not a problem. But let's say in the second pregnancy, we have, again, same mom who's RH negative. And if we have an RH negative baby, it doesn't matter. There's no antibodies present in a negative situation, so it's not a problem. There's no antigens present. There are lots of antibodies now. Lots of antibodies. RH negative antibodies. And they are on the lookout to make sure nothing with an RH plus is present ever. So if you are in the second pregnancy or third or fourth or whatever, and you have, again, an RH positive baby, there's a point in the pregnancy where suddenly the placenta becomes a little bit leaky, and those antibodies start going in and trying to attack the fetus. So one of these things that we have is our innate immunity, which is like antibodies that are always on the lookout for certain things you acquire from your mom. So there's a point in pregnancy where the mom starts giving the baby antibodies that she's already immune to, or antibodies that she's already produced to be immune to things. Well, the problem is if you're making this antibody that recognizes the baby itself as a problem, then you're going to get a agglutination in the baby, and that's very, very problematic. So we have this drug called, I think it's Rogam, and what it does is it goes and it makes these RH positive things a secret. It just caps them so that these antibodies never see it. So it's like the baby is invisible to those antibodies. And so then the pregnancy is fine and nothing bad happens. I mean, this is not going to be a problem in that blood system. This may be a reason. So a lot of times this leads to clotting way too much clotting in the organs, and it causes moms to bleed out. So during pregnancy or during birth, actually. So this could be a reason why a lot of people died in childbirth before drugs like Rogam were created. Okay, hopefully I didn't mess this up too much, and you kind of understand that if you have a blood cell that has an A protein on it, then you have A-type blood. That means if you have A-type and you don't have the B protein, the B antigen, that means you must be creating B antibodies to be on the lookout to destroy anything with that B protein. Okay? If you're type B blood, you have blood cells that have B proteins on them, B antigens, and you make antibodies for A, so you're on the lookout for any cells that have A on them to destroy them. If you're a negative and you've ever experienced RH proteins, you will have created RH antibodies to be on the lookout again to kill these cells, even though they aren't really problematic. If you have AB blood type, that means you have both the A and the B antigen, and you don't make any A or B antibodies because then you would be attacking your own cells. If you are O type, you don't have A or B antigens on the cells, no markers, and so you create A and B antibodies to be on the lookout for any foreign blood. Now, it seems like this is kind of a stupid system. Why would your body try and reject blood? It just happens. There's no reason behind it. It's an evolutionary thing. You see certain populations of people that have very specific blood types over time, like isolated populations like the Basque in Spain. They have a very high percentage of AB type blood, and I think it's one of these two. They have a very high percentage of, and it could be linked to other diseases. Maybe it is, maybe it isn't. It's something that it's not on the top of people's research lists, but it's an interesting question. It's just something that happens. It's something we know. We know you have to know somebody's blood type if you're going to do blood donations. A lot of times you hear people say that please donate. We're low on B negative blood. We're low on AB blood. Whatever it is. It's really easy to do a blood test and just do a really quick test. You just get a drop of blood, you put it in a plate that has its own antibodies for these things. And so if you have a plate full of A-type blood or A-type antibodies, and then you put a drop of blood on it that's got A blood cells, well, these are going to start clotting in a certain way, and you're going to know, hey, I have A blood. Awesome. Okay, similar thing, if you have AB blood, you have two wells that you put your blood into that have antibodies for A and B. If you then put your blood in both of those wells on that plate and you have clotting in both wells, you have AB blood. If you don't see any clotting ever in those blood plates, you are O-type blood, and so that tells you don't have any antigens, but you have lots of antibodies. Okay, hopefully this wasn't too muddled and crazy, and this makes a little bit of sense. Bye.